Hi guys, so we're going to talk about multiplying rationals, but this time they are not just monomials, or they just don't have one term in the numerator and denominator. As you can see, we have a rational that has two terms, and then we'll get to one that has three terms. And so it's a little different, but the thoughts and the methods are still the same. If you look at the previous ones that we did, what we did was we factored the numerators and we factored the denominators. We multiplied, which means we put the numerators and denominators together. And then we figured out what factors we had that were both in the numerators and denominators. And from there, they turned into ones, and we were left with what we had for our answers. We're going to do the same thing here. It's just that it's a little more complicated when we are factoring them out. We're no longer just allowed to break down the numbers. When we have binomials, which means we have two terms, or we have trinomials, three terms, we could even have four terms in the numerators or denominators, we have to think about factoring polynomials. All right, so let's get started. By the way, there's a previous video if you are confused on what I just showed you with that example that was just worked out. Please look at it. All right, so we're going to first factor our numerators and our denominators. 5 is already in prime factorization form. It can't be broken down anymore. It's just 5. T cubed can be t times t times t. All right. Now this is where it gets more complicated. It's not just one term. We have two terms here. So we have to think about factoring. And the first type of factoring that you're always going to check for is GCF. You're going to look for the greatest common factor. Whenever you have more than one term that you are factoring, you have to think about GCF. And I'm looking at 4, I'm looking at 8. I think that the GCF there is 4. That's the number that can go into both 4 and 8, the largest number that 4 can be divided by and 8 can be divided by. And so then if I divide 4t by 4, I'm left with just a t minus 2. If you need help with GCF factoring, there are plenty of videos on GCF factoring. Please look it up. I'm going to now factor the numerator in my second fraction and my second rational. Okay, it's not one term, it's two terms. So I'm first going to look for GCF. In this case, 6 would be my GCF. Be careful because sometimes it'll be a 6t. If there was another t squared here or something like that, then you would have a 6t as your GCF. So make sure you're paying attention to, one more. Make sure you're paying attention to the variables. So I have a 6. I'm left with just a t minus 2. And I'm going to divide that by 10 can be broken down. 10 is 5 times 2. So I'm going to have 5 times 2, and then I had a t there. Okay, so that is the only thing that is different from the previous examples where we just had one term in the numerator and denominator to these examples. From here, everything else is the same. We're going to multiply them, which means put the numerators together, put the denominators together. I like to put my parentheses, the factors that have parentheses, I like to put them in the back. So I'm going to have my 5 times 6, and then I have 3 t's, and then I have a t minus 2 divided by, I have a 4 times 5 times 2, I have a t, and I have a t minus 2. I'm now at the step where I'm going to figure out, whoa, I'm looking at something. I see that once I did my factoring with this right here, this 4 can be broken down to a 2 times 2. So I'm actually going to erase this. I'm actually going to erase this, and I'm actually going to write what it can be broken down as. Same thing with this 6. I factored out the 6, but if I were to actually pay attention to what it factors out to be, it can be broken down into a 3 times 2. So I'm going to erase the 6 and hopefully just the 6. Yes, nope, something else erased. What was it? Oh, a t. Okay, let's try one more time. We're just going to write that t back in. So that's really going to be a 3 times 2 times t. Okay, so that's something to pay attention to. So you're only going to do that with your GCFs though. You're not going to ever look at what you have left in the parentheses and try to break those numbers down. You should never have another GCF in the parentheses, but again, look up GCF videos. It'll help you a lot. All right, so now I'm at the step where I will cross off anything that's in my numerator and denominator. I have a 2 that'll cross off. I have a 5 that'll turn into a 1. I have just one t. It doesn't matter which one. I'm purposefully picking random ones to cross off. As long as I have one in the numerator that matches one in the denominator. I also, look. The parentheses, those factors are the same. So those turn into a 1. The same way that 5 divided by 5 is 1 and t divided by t is 1 is the same way that t minus 2 divided by t minus 2 is 1. I'm left with 3 times t divided by 2 times 2. That is it. So my answer would be 3t squared over 4. Here's another example. The steps are the same. I'm going to factor my numerators and denominators. I'm looking at this one and I'm noticing that every numerator and denominator is a binomial. So I have no monomials. I have 2 terms in each numerator and denominator, not just 1 term. So I need to first look for a GCF. I have a GCF here. This is a GCF of 2. So that'll turn into a 2, just a y plus 3. I don't have any more GCFs. The second type of factoring I'm going to look for is difference of squares. Every time I just have 2 terms that I'm factoring, I always look for difference of squares. And if you notice, I have a difference of squares. Y squared minus 16, that's a y times y gives me y squared. 4 times 4 gives me 16. And then all I have to do is put a plus or minus in between them. Bam, I factored those. Now, whenever you are factoring and you're using difference of squares, once you've completed your factoring, you're always going to look to make sure that these right here can't be factored anymore. And they can't, but always be careful because sometimes they will be able to be factored. All right, so y plus 3 can't be factored. There's no GCF. It's not a difference of anything. Y minus 4, there's no GCF. It is a difference because there is a subtraction in the middle, but y is not a square. Y squared is a square, but y is not a square. 4 is a squared, but y is not. It has to be a difference of squares. Both of them have to be squares. So you can't factor it anymore. I'm going to look to see if I factored out with my GCFs, if they can be broken down anymore. And this too is done. All right, so I'm ready to go ahead and write what the fractions turn into. They turn into a y plus 4, y minus 4 divided by 2, y plus 3. I'm going to multiply that by a y plus 3 and a y minus 4. I will end up with y plus 4, y minus 4, and even though that y plus 3 couldn't be factored, I need to make sure I put it in parentheses because it still is a numerator in itself. Divided by 2, y plus 3, y minus 4. So now I'm going to do the stuff where I look to see if I have any factors that are repeated. For my coefficients, I don't have anything, But I do see a y minus 4 in the numerators and denominators, so those turn into 1s. I have a y plus 3 in the numerator and denominator. Those turn into 1s. I am left with, ignore the doorbell, I'm left with a y plus 4 divided by 2. That would be my answer. Because it's just one term, you don't have to use your parentheses. If you had more than one, I mean, it's just one factor. If you had more than one set of parentheses, then you would need it. But because you only have the one factor, the y plus 4, you're good. That's your answer. I have a feeling somebody's going to start calling me in a second. All right, so here's the last example. So for my last example, I'm going to pretty much do the same thing. I got to first look to see if I have factors. I'm looking because I don't have any one terms. I have a denominator. Both of my denominators have 2 terms. Ooh, something fun is happening with that a minus 3 squared. And my numerators have 3 terms. So I have a whole new type of factoring I have to look into. All right, so first off, I'm looking to see if any of them have GCFs. They don't. Be careful because yes, this has a 3, this has a 3 in it, but this right here does not have a 3. Every term has to be divisible by the same number for it to be a GCF. Okay, so now I'm going to look to see if I have any difference of squares. I don't have any difference of squares. I do have a square here though. So I have a parentheses squared. So that really means is I have an a minus 3 times a minus 3. I'm looking at my numerators now and can't use difference of squares because it's 3 terms. I have to do another type of factoring, factor by grouping. I'm going to show you what that is right now. So with factor by grouping, you take your numerator, your denominator, whichever one you're trying to factor, and you have to look and multiply the first and last numbers. There's an imaginary one there. 1 times 9 is 9. So I'm going to talk to myself and I'm going to ask myself, what 2 numbers will multiply to give me 9, but then when I add them, I get -6, the number in the middle. I'm thinking about it. 3 times 3 is 9. -3 times -3 is 9. And -3 plus -3 is -6. Okay, it's -3 and -3. So I am going to rewrite my middle term, and I'm going to rewrite it as -3a. I just took the number from the first blank, and I'm going to have another -3a. I still have a plus 9. I still have an a squared. All right, so now I can actually start factor by grouping. So when you're factor by grouping, what you're doing is you're going to group the first 2 terms, group the last 2 terms, take out your GCF. Your GCF here would be an A. Your GCF here would be -3. Whatever sign is there will be the sign in your GCF. That's a good rule of thumb whenever you're looking at GCF and you're taking the GCF and the first term is negative. So when I factor out an A, I'm left with A, and then that'll just become an A minus 3. And then when I factor out the -3, I'm left with an A. 9 divided by -3 is -3. So my answer would be my GCFs in one parentheses and my twins, these are what I call my twins, they're always going to be the same, and my other parentheses. All right, so this numerator right here turns into an a minus 3, a minus 3. I'm going to do the same thing with the other numerator. I'm going to go a little quicker. If you don't know what I'm talking about when I say factor by grouping, look it up. There are videos out there. All right, so I'm going to change the color. I have a squared. Ooh, let's make that a little thinner. It's kind of bold. Apparently that's as thin as it'll get. Okay, so we're going to have a squared plus 3a minus 18. I'm going to go off to the side. I'm going to multiply 1 times negative 18 and get negative 18. So I'm going to say what two numbers multiply to get me negative 18. But then when I add them, I get 3. That's the term in the middle. Those numbers are it's a negative 18. So that means one's going to be positive, one's going to be negative. I think I'd like to do 6 times 3. If I have a positive 6 times negative 3, I would get negative 18. And if I have that same positive 6 plus negative 3, which is really just 6 minus 3, I'll get 3. So I'm going to rewrite it as, oops, I forgot, I changed the colors. I'm going to rewrite it as a squared plus 6a minus 3a, because again, I'm rewriting this middle term into two terms, and then I have a minus 18. I'm going to do the GCFs of this and this and factor them. They'll turn into a, and then I'll have an a plus 6 right here. This GCF, I have a negative 3 in both of them. That'll turn into an a plus 6, because negative 18 divided by negative 3 is positive 6. So this factors into a minus 3 and a plus 6. Again, the GCFs in one, the twins in the other. So a minus 3, a plus 6. So this turns into a minus 3, a plus 6. All right, so I factored them all out. I'm at the step now where I'm going to go back to the simple life. I'm going to write my factors, put them together into one fraction. I'm just going to go ahead and get to that step right now. I am going to only have parentheses here. Remember I said that I like to put my parentheses in the back. Well, if you only have parentheses, you'll have parentheses in the front and the back. Divided by a minus 3. Again, I have to make sure I put that in its own parentheses. And then that's an a minus 3 and an a minus 3. All right. I'm at the step now where, oh, 1, 1, 1. My answer is a plus 6. Now, if it was something else, I'd put it in parentheses, but it's not, so it's good. Now, there is a case every once in a while where everything turns into a 1. So there could be another a minus 6 down here. If that's the case, then your answer would just be 1 times 1 times 1 times 1. Your answer would just be 1. Don't freak out if everything crosses off. All right, we have another example for you. This example puts everything together. It's a beautiful example. All right, we have, ooh, this is just so beautiful. All right, here we go. First off, there's more than one term in each numerator and denominator. So we're going to be doing more than just breaking it down like the easy stuff. I look for GCF first. Ooh, this right here has a GCF. The second numerator has a GCF of y, so that turns into a y plus 3. Nothing else has a GCF I can take out. The second thing I'm going to look for is difference of squares. I have a difference of squares in the first denominator. So this turns into a y plus 3, y minus 3. Don't have any more difference of squares. This stays itself because it's not GCF, it's not difference of squares. I have a trinomial. I looked for GCF, didn't have one, but I will now have to do factor by grouping. Okay, let's do it. So I have a y squared plus 10y plus 25. Multiply the first number and the last number. I get 25. So I'm going to have two numbers that multiply to give me 25, but then they add to give me the number in the middle, which is 10. Two numbers. 5 times 5. It's the only two numbers I can think of that multiply to give me 25 besides 1 in itself. Okay, so 5 times 5 will get me 25. 5 plus 5 will get me 10. If it was a negative 10, then I would do negative 5 plus negative 5. All right, so now I'm at the step where I rewrite the middle term, y squared, using the numbers, plus 5y plus 5y plus 25. All right, GCF, I'm going to start my factor by grouping. I group the first, group the last. There's a y, and then that'll be a y plus 5. And then here I have a positive 5, and that'll be a y plus 5. So my answer for how that factors would be my GCFs and my twins. Again, you have to have twins here. Okay, so the first numerator turns into a y plus 5 times y plus 5. All right, so let's go ahead and rewrite it. So this is y plus 5, y plus 5. Oh, I forgot I had a y. So again, I like to put my factors that aren't in parentheses up front and the factors with parentheses in the back. All right, so I have a y plus 5, a y plus 5, a y plus 3. Divide that by y plus 3, y minus 3, y plus 5. All right, I'm at the step where I have to figure out if I have any ones anywhere. Yes, here you go. Yes, here you go. Anything else? Nope. My answer would be y plus 5 divided by y minus 3. And you can see what I was talking about, where if I didn't have this y in the numerator, then I wouldn't need my parentheses. But because I have the y in the numerator, I need to make sure I put the parentheses around the y plus 5. The y minus 3 has nothing else in the denominator with it, so I don't need to write a parentheses around it. But this right here would be my answer right there. If you have any questions, please leave me a comment. Again, this video is the next level up, and you really need to know how to factor polynomials in order to really comprehend what I'm talking about in this video. So if you don't know what I'm talking about with the GCF, and you don't know what I'm talking about with the factor by grouping, please look it up. Please look it up.